Welcome, physicists, to today's edition of Physics. In this short video, I'm going to look at how to solve problem 73 from chapter 2. In problem 73, we have a car that is stopped at a traffic light, starts from rest. As soon as the light turns green, a truck passes the car. The truck's moving at a constant velocity the entire time. So the truck is ahead of the car. The car speeds up at a constant acceleration of 2.2 meters per second, eventually catches up to, passes the truck, and continues on its happy little car life. Our task is to figure out where that occurs. How far away from the traffic light does the car pass the truck? How much time has elapsed? And how fast is the car going when it gets there? So that's what we're going to do. Let's see how to do it. Let's begin by identifying what information we know about the car and the truck respectively. We know the car starts from rest, has a constant acceleration of 2.2 meters per second squared, travels a displacement of delta x in a time delta t. We know that the truck is moving with a constant velocity of 9.5 meters per second and has an acceleration of 0, travels the same displacement delta x in the same time interval delta t. Now that I have my given information, I'm going to set up an equation for each object, the car and the truck, and I'm going to use the displacement is equal to 1/2 at squared plus v naught t for each. For the car, I know the initial velocity was 0, so that term drops out. And for the truck, I know the acceleration was 0, so that term drops out. I do not know the displacement of either object, but I know that they have to be the same displacement because the car is passing the truck, so they both have traveled the same distance. Therefore, I know that if the displacement of the car is equal to 1/2 at squared and the displacement of the truck is equal to the velocity of the truck times time, I know that those two terms have to be equal to each other, right? Math. If A equals B and B equals C, then A has to equal C. It's some property of math. I don't know the name and I don't care. I know that the car's term equals the truck's term. I'm going to go ahead and change my subscripts to AC for the acceleration of the car and VT, the velocity of the truck, just to kind of keep my mind a little bit more organized. With this, I can solve for the time. One of these roots drops out, and I get the time of the event is equal to 2 V of the truck over acceleration of the car. Once I know the time, I can then plug that into either equation to solve for the displacement. I'm going to choose the truck because it's not squared. Once I know the time, I can then plug that into the equation for the final velocity of the car. I'm choosing to use final velocity is equal to initial velocity plus AT. And I got that the car is traveling with a speed of 19 meters per second. So there you have it. We saw how we can use a system of equations, two equations and two unknowns, to solve for the displacement, the time, and the final velocity of this car. That's all for this episode. We'll see you in the next one.